Alright, this video is going to be about standard form of a linear equation. Make sure you realize this is for linear, because standard form for quadratic would be different. Okay, so standard form for a linear equation is in this form of ax plus by equals c. And in this form, we're going to say that a, b, and c must be integers. So just to remind you, integer means that they're not going to be decimals or fractions. They're going to be whole numbers or their opposites. Something else to remember is that a is generally accepted as being positive when it's written in standard form. I've seen it written both ways, but most of the time when we say standard form, we're wanting the a to also be positive. And also, a and b can't both be negative, because if a and b were both negative, then I would not have an x or a y, and therefore I wouldn't have something that was linear. So they can't both be, sorry, I think I said the wrong thing. I think I said they can't both be negative. What I meant to say was they can't both be 0. If they were both 0, then we wouldn't have an x or a y, and so it would not be in standard form. Okay, so those are some things to remember. So what we're going to look at first is I'm going to show you some equations, and we're going to rewrite them so that they are in standard form. And then I'll show you a couple where when we have it in standard form, how you would get the graph of it. Okay, so for our first example, let's say I have y equals negative 2x plus 5. So remember, my standard form is ax plus by. The important thing to notice about that is the x and y have to be on the same side of the equation. So I'm going to take my x term and I'm going to move it to the same side where the y already is. So since it is a negative 2x, I'm going to add 2x to both sides. That's going to make this 2x plus y equals 5. Okay, so I've got my x and y on the same side. A, b, and c are integers. A is positive. A and b aren't both 0. So this would be my equation in standard form. 2x plus y equals 5. Alright, so let's look at another one. Y equals 2/3 x plus 7. So just like I did on the other, I'm going to move my x term. So I'm going to subtract the 2/3 x. That's going to make this a negative 2/3 x plus y equals 7. Now the problem here is that the a, the number in front of the x, is not an integer, it's a fraction. And it's also negative. So I'm going to multiply my whole equation, because I can't just multiply one term. I'm going to multiply my whole equation by the denominator, and I'm going to multiply by a negative also, so that because a negative times a negative will make that term positive. So I'm going to multiply everything by a negative 3. So negative 2/3 times negative 3 is going to be a positive 2x. And then I've got y times negative 3y, or negative 3, that's going to be a negative 3y, or minus 3y. And 7 times negative 3 is negative 21. So 2x minus 3y equals negative 21 would be my equation in standard form. Alright, so let's look at one more. So let's say I have 1/4 x equals negative 3/5 y plus 2. So I'm going to add my y term, so it's on the same side as the x. So that's going to give me 1/4 x plus 3/5 y equals 2. So I got the x and y on the same side, but I need to get rid of these fractions because those are not integers. So this time, since I have more than one fraction, I'm going to have to look at the two denominators that I have, which are 4 and 5, and decide what is it that I need to multiply by. So I want to think about a common factor, or the, sorry, not a common factor, but the common multiple. So what is a number that 4 and 5 both go into? And so that number would be 20. So I'm going to multiply by 20. 1/4 times 20 is going to make this 5x. 3/5 times 20 is going to make this 12y. And 2 times 20 is 40. So when you're multiplying, make sure you remember to multiply every term. So we end up with 5x plus 12y equals 40, and that is in standard form. Now let's look at, so let's say that I have this graph, and the equation I want to graph is negative 4x plus 6y equals negative 24. So this is already in standard form, so I'm not going to have to worry about that this time. What I do have to worry about is I need to know how to graph this. We've graphed from slope-intercept form before, but this is completely different. So we're going to do this by finding the intercepts. And so if you'll remember intercepts, if I draw myself a graph here, intercepts are going to be where this crosses on the x-axis or where it crosses on the y-axis. And if you think about it, anything that's on the y-axis has an x value of 0. So to find the y-intercept, I'm going to put in 0 for x, like this. Well, negative 4 times 0 makes that 0. So I really just have 6y equals negative 24. Divide by 6 to get the y by itself. And that is y equals negative 4. Now remember, I put in 0 for the x, so I actually got this ordered pair 0, negative 4. Okay, now if I think about what an x-intercept is, it is something that is on the x-axis. And anything on the x-axis has a y value of 0. So to find the x-intercept, I'm going to put in 0 in place of the y. So that would look like this. So 6 times 0 makes that 0. So this is negative 4x equals negative 24. Divide by negative 4. And x is 6. So I have 6 for my x value, 0 for my y. So 6, 0 is my ordered pair. Now if I plot these 2 points, 6, 0, and 0, negative 4, and then all I'm going to do is draw a line through those 2 points. And that is how you graph it when it's in standard form. So find your x-intercept by putting in 0 for y, find your y-intercept by putting in 0 for x, plot those 2 points, and draw a line through.